Welcome everyone. A new day and we are back with a new problem. Today's problem is top K frequent elements, and this is one of the problems within the blind 75 list, and I love this problem because I learned some new concept myself from this problem. So I'm going to share with you. So the problem description says we are given an integer array and also an integer. So two things, an integer array and an integer k. Okay, so integer array nums, integer k. We have to return the k most frequent elements. You may return the answer in any order. So that means we are given an array of integers and we have to return the top k or the highest valued k elements from that array. Okay, so for example, you see here for the first example, we have this array 3 ones and 2 twos and a 3, and the value of k is 2. So the top two elements are with the highest frequency are you see one has frequency of 3 and 2 has frequency of 2. So these two are the top two elements, right? Okay, for the example 2, you see that we are given just one, the array contains just one number and k's value is 1, so we have to return 1, right? That is the only element and it has the frequency of 1, and that is, yep. Okay, so before we start, we always have to ask a few questions to the interviewer. One of the question is like, can there be like multiple set of answers, or it's just a unique answer? For these examples, suppose they say that it's guaranteed that the answer is unique. Our idea is like count all the frequencies um, of different numbers or different integers in a hash map, and then we have to somehow like sort them. Well, or what we can do is we can just keep a min heap and then try to min heap of size k and try to insert all the elements one by one according to their frequency. Uh, and that way the heap will contain only the highest k numbers, right? And then we read from the min heap. So let's see how that works. So say the input here was 1 1 1 2 2 3, right? So the idea here is what we want to do is we first want to build a map, hash map, where the key is going to be the values of the numbers, and uh, the value is going to be the frequency. Okay, so you see it will look like this. 1 has come 3 times, and then 2 will have a frequency of 2, 3 will have a frequency of 1, right? Okay, so putting into the hash map, if the input array is of size n, we know that putting into the hash map is order of 1. So adding to the hash map, will take n into order of 1, which is order of n. So in order of n time, we can just put the elements into the hash map. Now we have the frequencies. So how do we get the top k? So we have all the frequencies. What we have to do is we have to get the top k. So if we get a say min heap will look like this, right? Just look something like this. Say the min heap, we say that the min heap of size k. That means the min heap can contain maximum of k elements, and then we keep on adding these. So, and the min heap is actually based on the frequency. So that means the minimum frequency element will be at the top. So this will put the minimum frequency, right? So what if we just try to add like each of these pairs into the min heap? So we add this into the min heap, and then we add this, and then we add this. So what's going to happen is, in that case, only the top k elements, top k frequent elements, right, will remain in the queue. Because what's going to happen is, the top of the main heap is going to have the minimum element, right? Minimum frequency element. And once another element is going to be there, if that one has a higher frequency, this thing will get eliminated, right, and replaced by that one. Okay, so since the size of the heap is like order of is at most k, so the insertion into the heap is log k, right? And in total we have like n insertions, right? N insertions, so n log k. So that is the insertion part. So order of n log k is the insertion part. And then afterwards, the last thing that we have to do is uh, we have to read from the heap, right? So there are k elements in the heap. So as you see, the total time complexity is going to be order of n plus order of n log k. So these two, adding these two, and that is actually order of n log k. And the space complexity, let's talk about the space complexity. You see, we need at most n space here, right? Order of n space here. And here we need order of k space. So the total space complexity is going to be order of n plus k. So that is the space complexity. So this is a pretty not a very easy one, but a straightforward thing, algorithm in order of n log k. Okay, so let's go to our problem discussion again. And you see there was a follow-up. It says your algorithm's time complexity must be better than order of n log n, right? So the question is, can we do better? The answer is yes. So this is something that didn't came into my mind immediately. I actually had gone through this problem and looked at the solutions, and then I learned it. So this is the concept is bucket sort. So the idea here is, you see that we have these elements, right? So can you tell me that what is the maximum frequency of any element that we can have, right? If we have n elements, so here we have like six elements for this example, right? What if we had like 6 ones, right? That's totally possible. That means the max frequency can be, so the max frequency can be n, right? With an array of size n, the max frequency can be n, right? Okay, so we create buckets. So this is actually an array. Let's create an array. So the array will have the indices 1, 2, 3, 4, 5, 6. Okay, so we'll have an array of size n. That is, if this is the n, if the frequency of these input array is n, then we'll create an array of size n. So we call it a bucket of size n. And these indices are going to represent the frequency of the numbers. So the indices are actually the representation of frequencies. So the indices are the representation of the frequencies, and each value here will represent the number itself, like the number that has, so this value is going to be the number that has frequency of 3. So what is going to be here? 1, right? 1 has a frequency of 3. And then none of the elements has a frequency of 6, so we put 0. None of the elements has frequency of 5, none has frequency of 4, but 2 has a frequency of 2 and 3 has a frequency of 1, right? So the values are going to be the actual input values that has the frequency of this index, right? Okay, and we know that the maximum size of the array is going to be the size of the so this, okay, so size, input array size is this. So bucket size is going to be n plus 1. The reason behind that is, if the array size is say 6 here, then the bucket size needs to be 7, because we want index from 0 to 0, 1, 2, 3, 4, 5, 6, right? To incorporate this index number 6, we have to get a bucket size of 7, right? So that's exactly what you see here. And then we put the values here. And then afterwards, okay, so here is another important thing. So say your input might be like this, 1, 1, 1, 2, 2, 2, and then 3, right? Okay. So in that case, you see that this one, the input array size is 7. The bucket size we had to put 8, right? So we had to put another bucket because the maximum element could have a frequency of 7. So we add another one. So this will look like the bucket size. So we are focusing on these input array now. And as you see that there are actually 2 elements with a frequency of 3. So 1 and 2. And there is no element with frequency of 2. And there is just one element that is 3 or frequency of 3. So you see we have 2 elements. So that means this has to be a list, right? This value has to be this. So the bucket, actually the bucket is a array of list. Bucket array is an array of list. That is an important to remember. Okay, so we got this bucket, 6 buckets, and now we want to take the top uh, like top k frequencies. So how do I do that? I start reading from the end, right? Read from the end. And so let's use another color to represent this. So I start reading from the end because the highest frequency is at the end, right? And then we keep a result and we keep on adding. We know that we have to add k elements. So there is nothing here, nothing here, nothing here, nothing here. And then we found 2 elements here, 1, 2. And we are done because the value of k, say the value of k was 2, that we had to find the top 2 elements, right? Now let's talk about the, as you see, this was like a very interesting concept. Let's talk about the time complexity. So obviously this one takes order of n, creating the hash map and the frequency map, and then putting into the bucket. Putting into the bucket actually takes also order of n, because what we do is we read one here, we see a frequency of 3. What we do is we just go here to the index 3 and put 1 here, right, inside it. So we just have to read n elements and insert into the bucket. So the insertion is also order of n. Okay, so first, starting over again, inserting into the frequency map is order of n. Inserting into the bucket is also order of n. And then final step is reading from the bucket, right? Or bucket array. And that one actually is order of n because we go back, right? And there are like at most n elements to be read. So in the worst case, this reading is also order of n. So this is order of n. This one, okay? This is also order of n. So in total, we have like order of time complexity is going to be order of n. And space complexity is also going to be order of n. The reason is we have 2 things. Well, we have the frequency map, right? Frequency map is of size n. And also we have this bucket array of size n. Okay, so let's go and code this. Okay, so we have to have a hash map of value and their frequency. So both of them are going to be integers. And then we are going to have this array of bucket, as we said, like this is going to be an array of lists. So this list is going to be of size size of the input array plus 1, as I explained, right? And then we'll have a result array list. Let's put it in a list. Okay, so you see that the result is going to be an integer array. So we can create a list of result and then convert it into an array. Then we will read from the input array and put it into the frequency map. So the element might not be in the map yet, so we'll use get or default. And the key is like frequency, and the default value is 0. And then we'll add 1 to it. Let's turn this off. Okay, so now all the frequencies are in the map. Then we'll read from the map. Read each of the values from the map. Get their corresponding frequency. And then we'll put the values, this value in the, or let's say this is the value, and then we'll get the frequency, and then we'll put the appropriate values into the correct indices in the bucket. So we have to first check if that bucket is still null. That is null, then we have to create an array list. This is for the first time. And then in that array list, we have to add the value. Okay. So now everything is in the bucket. We have to start from reading the bucket from the end, right? We have to keep on doing this until the size of the result is less than equals to k, less than k. And then result dot add all, everything in the bucket is going to be added because those are the top items. Okay. And finally, we have to convert this into a into an integer array because of because of the problem here. So probably in the interview, they are not going to tell you that this is an integer array. So you will just can return from the result. But here in this problem, since it tells you, let's say int answer equals to new integer of size k. So we have to convert it into an array of integers to return, say ans. This is the size of the array is going to be the size of. Next, we read from the result list and have to put into the array. That's simple. Okay, so let's take a look at the code if there are any errors. Okay, so in the buckets, some of the buckets might be empty. So we have to make this checking if, because there might be few frequencies which no number has that many frequency. Another mistake that I made here is here. I have to start the top frequency and then reduce it by 1 every time. So let's see if we have any more errors. Okay, so here you see that we have to put for the value, not for the frequency. So I have to change it to I. Let's run this. Accepted and then submitting it. Okay, so you see this got submitted and this is our order of n algorithm. Thanks for watching and we'll come back with another problem next time.